Now, how electricity flows, what is electricity itself? In order, there's no, a short and a definitive answer to that. But in order for us to understand how electricity works, which is basically a movement of electron, it's important to understand how atoms work. What is an atom? So atom is the smallest particle of an element. The three principal or building blocks of an atom are electron, neutron, and proton. So what you see over here is basically the center part of the atom, okay, which is known as the nucleus, okay? This is referred to as the nucleus, okay? Inside this nucleus, you have protons, which is right here as P, and you have these neutrons, okay? Neutrons are neutrally charged, protons are positively charged, okay? And then you have these electrons, which is actually revolving around the nucleus, okay? And those are negatively charged particles, okay? In a stable atom, your number of protons and number of electrons are always going to be same. So your number of protons are always going to be equal to number of electrons, okay? So if you take an example of the hydrogen, who has an atomic number of 1 means it has one proton, and that would also mean it has 1 electron, okay? These electrons, they revolve around this orbit. The farther they are from this nucleus right here, the lesser the force of attraction would be between them. And why is that? Because remember, your proton is positively charged and your electron is negatively charged. There is going to be a force of attraction between them, and they will be tightly bonded, okay? So if you have an electron over here, say, because this electron is farther away from the nucleus, the force of attraction between these two will be lesser compared to that of electron over here because it's closer, okay? So let's move on. In an atom, the electrons are arranged in shells at various distances from the nucleus according to the amount of energy they have. Okay, you can correlate to what I just said, electron being close to the nuclear as is tightly bonded and there's a stronger force of attraction, whereas to the electrons that you see here in the outermost shell, they are, the force of attraction is not the same. Now, what you need to learn over here is, again, you have this nucleus over here, okay? This shell right here, okay? This shell, or also sometimes also referred to as level, okay? They're calling it shell. This is shell number 1 right here, okay? This is shell number 1. This shell can have a maximum of 2 electrons, and that's where you see 1 electron over here and then 1 electron over here, okay? If you go to the next shell, which is this one right here, okay? This shell can have up to 8 electrons. We use letter L to denote that, okay? And similarly, you have shell 3, shell 4. Each shell can have a certain maximum number of electrons, okay? So if I look at this electron right here, which is actually pretty far away from the nucleus, remember nucleus contains protons and neutrons. Protons are positively charged, and each electron carry negatively charged particles, okay? They are loosely bonded. So if I apply any external force, okay, or to this electron, this electron can be ejected from this and then just float in some free space, okay? And when this electron, if ejected from the shell and then floats in a free space, that's what we refer to as electricity. So when you have heard this definition many times, electricity is a flow of electrons. That's what's happening. The electron is being knocked out from the outermost shell of the atom, and then it's freely available to float, okay? And when it floats and it moves, that's what creates the electricity, okay? So let's go here. Now, I have a periodic table over here, and one of the reason I have it over here because I wanted you to have a good understanding of, what conductors, insulators, or metals, non-metals are, and how it is defined from their atomic number. Okay, so if I look at this right here, copper, this represents 29, that's the atomic number. Okay, and underneath that you also see 63.546 atomic mass unit. That's the mass of the copper. Okay, copper has 29 protons and 29 electrons. So remember, you have copper here, which has atomic number of 29. Okay, all right, so the first shell, which is referred to as K. Okay, again, remember this is nucleus and we've got proton positively charged. Your K shell can have how many electrons? Real quick. Yes, folks. Two. Okay, so you have one electron over here and say one electron over here. Okay, we need to add these electrons up that it makes 29. Okay, let's move to the next shell, which will be the L shell. Okay, how many electrons you can have over here now? If I go back here, your L, you can have up to 8 electrons, correct? So remember, these electrons are usually in pair like this. 2, 4, 5, 6, 8. Okay, 2, 4, 6, and 8. Then I move to the next shell, KLM, which will be M right here. Okay. Okay, your M shell can have up to 18 electrons. Okay, up to 18 electrons. So 2, 4, 6, 8, 10, 12, 14, 16, and 18. Okay, now I got K equals to 2, L equals to 8 electrons. Okay, M equals to 18. If I add them up, I get what? I get 28, right? 10 plus 8 is 28. But the copper has an atomic number of 29, so there's one electron missing. So because I have reached the limit for shell 18, I'm going to have to move to the next shell, which is going to be N. So this shell is over here. And this shell will have how many electrons? Because there's only one electron remaining, this electron will be just sitting lonely in the outermost shell. So K here is your level 1. Okay, K is also referred to as level 1. Okay, L is your level 2. Okay, you have M, which is level 3 here, and then you have level 4, which is the outermost shell. Okay, so that's how the electronic arrangement, the arrangement of the electrons going to be for every element. You basically look up this table right here, and then you assign the electrons to each shell, and then see how things goes. Okay, now in this case, because it has one electron in its outermost shell, first electron like to be in pair. Okay, this is not in pair, so it's extremely agitated. It's looking for a partner. Okay, and because it is also far away from the nucleus, so the force of attraction between the two is also lesser. So any external force applied, this electron will be knocked, and this will be floating in a free space. Now, do you know why now copper is a good conductor and it's used in the electric circuits? That is the reason, because it has one electron in its outermost shell, and it is also referred to as a valence electron. What are valence electrons? Valence electrons are those electrons which are present in the outermost shell. In this case of copper, it's actually 1. Okay, so there's one valence electron that copper has. This information is also useful to find out the valency, group number, and period number of the element. Now we are actually at level 4 here. Okay, so that means the period for copper is 4. So you have this period right here. This is the first row is period 1, 2, 3, and 4. Okay, so if you notice here, copper is actually in the 4th row. Okay, and that's because the outermost shell is the level 4. Okay, now it has 1 electron, it's in its outermost shell. That means it has a valency of 1 and it belongs to group 1. So that you see 1b right here. From this information, you can find out that this belongs to 1b. 1b basically means this is a transition metal. Okay. You also see hydrogen has 1 electron, but it's considered as 1a because it is characterized different. It is a non-metal. Okay. Okay. So with this atomic number, this copper being 29, you were able to find out the valency for this copper. You were also able to find out the period number right here and also the group number. Okay, and obviously we now know because it has 1 electron in its outermost shell, it's very conductive, and it's one of the most that's one of the reasons it's widely used in the electric circuits. Now there's another way to do this, and that is through Aufbau Principle. Okay, I hope I spelled it right. What is Aufbau Principle? So remember, you have these levels here, right? So you have this nucleus right here, and then you have these levels, level 1, level 2, and so on. Okay. Each of these levels have sub-levels. Okay. So say the first level has S level, S or a sub-level. Okay. The second level has 1s and 1p. Okay. And similarly, if you have another level, okay, that has S level, P level, and D sub-level. Okay. Let me just maybe use a different color here. Yeah. You have S here, P here, and then D. Okay, so what is the difference here? Now, in an S orbital or S sublevel, so these are the orbitals or sublevels. S can have 2 electrons. Okay, okay. Remember, the first level was referred to as K in the previous slide, and you can have up to 2 electrons. Okay. Now, in the second level, you have 1s, 1s, and 1p. P has 3 orbitals. Okay, and each orbital can have a maximum of 2 electrons. So 3 times 2 electron means 6 electrons. Okay, so if I look at the second level with 1s and 1p, can you tell me the total number of electrons will be what? Yes, folks. The total number of electrons will be what? If you look at the S, you have 2 electrons, right? For the P, you have 6 electrons. If you add 6 plus 2, you get what? 8, right? And that's what you had in the previous slide, where L can have a maximum of, if I go back here, L can have a maximum of 8 electrons, right? 8 electrons right here. Now, you also have another orbital, which is D. D can have a maximum of 10 electrons. And then you also have F right here. S can have 14, I believe, yeah. 14 electrons, yeah. Okay, all right. Now, the way it follows is basically follow this sequence right here, what you see over here, okay? The first sequence, it starts with this orbital, which is 1s, 1s, and S can have how many? S can have 2 electrons, okay? S can, again, we are doing it for the copper, which has the atomic number of 29. Okay, 1s2. In the subscript, superscript, you basically write the number of electrons that orbital can have. Then after 1s, it goes to 2s, okay? S orbital can have how many electrons? 2 electrons. You have 2s, and then you write 2. Then you have what? Then you go this way, then you have 2p. You have 2p6 because p orbital can have how many electrons? 6 electrons. Okay. Then you go to 3s, 3s2. Then you go to 3p, 3p6. Then you go to 4s, 4s2. And then you go to 3d. Okay. 3d, d can have how many electrons? D orbital can have maximum of 10 electrons, so you get 10. So let's now add the superscripts. You have 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6 is 18, 18 plus 2 is 20, and 20 plus 10 is 30. Whereas the electrons in copper are 29, so we have basically we would have what? We would have, instead of being 10, this would be 9 over here, because the number of electrons cannot exceed 29. But what's going to happen, what you see over here, 1, 2, 2, 3, 3, 4, and 3, these are the levels, right? These are the levels, correct? Okay, before the electrons move from one level to another, they will actually fill this level first before they can move on to this level. Okay, so this 4 level, S, you have 2 electrons, where D has 9, but it needs 1 more electron to complete its orbit, because D can have a total of 10 electrons. So can you guess what is going to happen before it moves to the 4th level? The 3rd level needs to be complete. So how will this work out? Anybody suggestion here? Yes, folks. 3d10, okay, and 4s1. So that is absolutely right. And who is that? Ashish. Okay, so what I'm gonna do, I'm gonna change this 9 to 10. Okay, now the 3rd level is complete and 1 electron less on this. Okay, now what is the outermost orbit now? It's 4. Okay, so that means it belongs to the period of the copper in the periodic table is 4. Okay, okay, all right. What is the number of electrons? Electron is 1. That means it has a valency of 1. Okay, and also it belongs to group 1 in the periodic table. Okay, now if I ask you, copper is a donor or acceptor? Copper is a donor or an acceptor? Mean it will donate the electron or it will accept the electron. See, copper may have 2 options, right? One option could be s orbital needs 2 electron. It currently has 1 electron. It can have 1 more electron and be stable, right? Or it can just get rid of this electron and become a donor. Okay, so more likely possible option for copper is to donate that extra electron that it has in the outermost shell. Okay, this is very important to, I know this is a little bit of chemistry and you might not have enough background to understand this, but this is important to understand like where I'm heading towards explaining electricity. Okay, so Vignesh, you are right, just 1 in the outer shell, easier to donate. Okay, all well so far? Everybody following me along?
Far so good.
Okay, good, perfect. Now let's move on to the electricity. Electricity is a form of energy and it is a flow of electrons. Okay, flow of electrons. Electricity could be found from secondary energy sources through an energy conversion process. Energy like coal, natural gas, oil, nuclear power, hydropower are called the primary sources. America produces most of its energy by burning coal, basically fossil fuel. Roughly 11% of the energy comes from the renewable forms, and the most widely used renewable energy form is the solar cells. Okay, and then we have wind turbine, biomass, and others. Okay, now focus on this graphic. Okay, think of this graphic as this shell represents the 4th shell. okay? Fourth shell of copper, where you have how many electrons in the fourth shell? You have 1 electron, right? And that electron is revolving around the nucleus, which is positively charged here, correct? Okay. Now, any external force applied, or this electron being close to each other with the neighboring atom, what is the electrostatic force Coulomb's law suggests when the like charges are close to each other? What does it say? They repel each other. And the closer they are, the more force they would apply on each other. And when that happens, the electron will be knocked out of this orbit, right? And it may latch onto the neighboring atom because the positive charge will attract this negative charge electron towards, and this will keep on happening. This will keep on happening, and it becomes a chain effect, as you can see in the graphic. And once this electron is flowing in the free space like this is what referred to as electricity. And that's where copper is an extremely important element on the periodic table, because it only has 1 electron in its outermost shell, far away from the nucleus. The force of attraction, the electrostatic force between the two charges are pretty less. Any significant external, not significant, any even tiny forces applied, external force that could be voltage or any disturbance, could knock out the electron, and the electron may eject and may just start flowing in the free space. And that's what we refer to as electricity. So if I was going to explain you what electricity is on a very like atomic scale, the deepest I could go, that's how, you know, electricity works.